Thank you. So I thought, like, rather than use slides, I just thought I'd kind of talk for the 10 minutes we've got before the break. Just as a kind of I'm going to kind of talk through some of the things I've done as a little bit of an illustration about the benefits of what I kind of annoyingly described to some of my colleagues as a real computer science education. So I was here from 1986 to 1989. And one of the things, again, I push back on a lot of people. There's a little bit of a vogue sometimes in various circles to say, well, look, I got my education and I went on and, I never really used it in my career. The thing that kind of I think about this place every day, and I'm not doing that because this is the 50th anniversary and I'm speaking in front of you all. I literally think about this place every day because I've been fortunate in my career every single day to use some part of the foundational knowledge that I got from a 3-year computer science degree in a place and in a time, and I'm reliably told by the staff here, it's still this case, in a time and a period and a place where you could do everything from the physics to the people. And every part of that has somehow benefited me. So I'll start giving you some examples of the stuff I've done, not as any kind of form of self-aggrandizing CV, but literally just to kind of illustrate this concept. So after leaving here, I did a master's by research at the Programming Research Group in Oxford, and then I also was doing some work for the Royal Navy on real-time systems development for submarine warfare systems, and all of that was written in Ada. And I had a very well-thumbed book written by Professor Pyle on the Ada programming language, and a big part of my second and third year studies here on real-time systems development, thankfully, were done in Ada because I got parachuted into this project when I worked for Logica Space and Defence System, working on this Royal Navy contract where we had to build everything in Ada. And I think I was the only programmer on that team that had actually done any development in Ada at the time, and everybody else was busily scrambling to kind of go through that. So that was a fantastic experience. And also, by the way, it's funny you mentioned numerical analysis, because I did second and third year numerical analysis, which I found an absolutely fascinating subject. And so this project, Submarine Warfare Systems, was a lot to do with sonar guidance, and there was some pretty heavy math in terms of kind of analyzing what you did with sonar and turning it into kind of actual actuation of weapon systems. And again, a lot of it was how to think about taking some very complex mathematics into actual code that could perform well in Ada. But one of the things, it's not all sunshine and light, because one of the interesting things about this was, and this is where I got to use some cross-compiling experience, is even though the Ministry of the Defence at the time required everything to be developed in Ada, most of the computers that you could actually got to run these things on were radiation-hardened machines whose machine code were not capable of running what was output from the Ada compilers at the time. So you had to do a whole bunch of kind of cross-compiling, and then you still had to provide some kind of arguments about the software validation and verification, which then came in my first and second year courses around kind of software validation, formal construction of programs, and a whole array of other things. So the next part of my career, continuing the theme of working in kind of not politically correct industries, I went to work in the oil and gas industry on North Sea oil platforms. Again, building things, real-time systems, various different programming languages, various different techniques, all of which required some degree of logical reasoning about the performance of programs. This was also a time when I started getting to mess around with building on my knowledge of operating system design. Because believe it or not, there were some oil companies at the time, but this was even before Linux. So this was when people were taking kind of various kind of license grant operating systems of things like VMS. Some of you may remember this is going back, it's depressing when you're outside in the room for people of my age seeing computers that you've actually used that are now museum pieces. And so, some of these things we were taking kind of very early versions of Unix, very early versions of the DEC VMS operating system, customizing them, adjusting the kernel so that it would have different real-time properties for what was needed in kind of real-time oil and gas platform sensing. And again, I had no idea whether I'd have been clever enough to figure out how to do that myself without some part of the education from this place. Moving on from that, again, even my career is gradually descending in terms of politically incorrectness. I went to work for a whole series of banks for a number of years. So in the 1990s, I was building some of the first first internet-connected banking systems. And so again, this was at a time in the 1990s when you could build a website, you logged in and got your balance, and that was the coolest thing ever. And again, this was before you could really buy internet firewalls, so we had to build them. This is before you could buy intrusion detection systems, so we had to build them. This was before you could buy any kind of construct, and this was actually what was called SSL then, it was now called TLS. It was before all of that, and we had to build all of those protocols ourselves. And again, this is where it came really handy. I had some of my network knowledge, some of the distributed systems knowledge, a lot of the other stuff. And again, the backdrop of this, I always remember here a third-year class where they first introduced us to working in teams. Like, who'd have thought that? And how to do collaborative software development. And again, it's just, it's kind of cliched now, but at the time, everybody's mental model of a computer programmer was people just sit and write programs, not necessarily collaborate. And a big mark of the success or failure of most organizations is the ability to operate large-scale teams. And that's still a challenge today. We don't necessarily have the software crisis, we have the teams crisis in most organizations, and that's still a very, very hard problem. But I was thankful to have kind of the introduction to kind of working in teams, and that was vital. The other thing I then did was spent a lot of time building cryptographic software for some of the first UK and European high-value payment systems for banks, and again, second year coding and cryptography class here was vital to that as well, which gave me some foundational knowledge for that. Moving on from that, again, the theme, did remember declining political correctness. I went to work for Goldman Sachs for 20 years, and which is actually a fantastic company. That first introduced me to the fact that not all media tell the truth all the time, that the external portrayal of an organization being very different on the inside. And again, this is another example where I got to actually use my, some of you may remember the Dragon book, the compiler book. So I got to use that quite heavily because, believe it or not, Goldman Sachs still today has a proprietary internal computer programming language that was specifically designed for certain types of financial modeling and financial processing. So it's a language called slang, and it was an early version of the graph theoretic programming language. We built a compiler that literally, and I remember kind of, going through, Lex and Yak and constructing compilers, and we're working on this. Again, fascinating that, what was this? This was now kind of nearly 12, 13 years after this place. I'm actually then, remembering knowledge from compiler design class here, which was great. And so I then kind of spent many years doing various different security projects. I was Chief Information Security Officer, then Chief Risk Officer. And then I was a board director where we kind of oversaw all of the work on the Apple Card with Apple. And again, that was a lot of work going on kind of the virtualization of credit, virtualization of credit card numbers, and many other innovations that help the promulgation of really effective, secure financial technology. Now, I'm kind of hoping this is like an uptick in political correctness. That I now work for Google, but I know some people have kind of different views of Google. So for the past 18 months, I've been the Chief Information Security Officer for Google Cloud and Google Workspace and a lot of our infrastructure. And one of the things that's kind of even nicer to be back in a real hardcore computer science environment. And again, we're getting to work, we work on so many different things, thinking about computing at literally planet scale. So, for those that you don't know, we pretty much build everything ourselves. We've got 4 ships at sea at the moment laying undersea cables, so we're putting most of our undersea cables down there. We build our own hardware, we build our own data centers, we're building our own processors. And so we're the classic kind of vertical integration of technology, for the simple reason is we're having to solve computer science problems that are not being solved by commercial vendors of other software and hardware that we have to build into our environment. And this kind of evolution of what we first called warehouse scale computing, that we're now kind of thinking of truly planet scale computing, is something that is going to be a tremendous challenge. We're pushing the boundaries of computer science in many respects and partnering with universities. And one of the big things that we're doing as part of all of this is the thing that I'm most focused on, which is cybersecurity, which is not just now niche discipline of defending certain things. It pervades everything that we do, whether it's because it's needed for privacy, it's needed for regulatory compliance, it's needed for the protection of organizations around the world, the protection of critical infrastructures against nation states and organized criminals. It pervades everything we do. And again, security in microcosms is tractable. Security at planet scale is what you might slightly describe as a hard problem, and we continue to work on that, and doing that in a way that gets around a lot of the trade-offs in terms of performance, resilience, reliability, all of the other things, and making sure that we're trying to do this in a trade-off free environment as we possibly can. And I give you kind of one final example of harking back to this place. Was a few years ago, and this, I've dealt with this before and after Google. Many of you will be familiar with vulnerabilities in processor design, the so-called meltdown and Spectre vulnerabilities. Now, we've been dealing with this for a long time now in various different ways. I remember when those attacks were first postulated, again, a lot of my colleagues were really struggling with this because there's a lot of software engineers in the world today that have no concept of what's going on down at the hardware level. And one of the things I remember second year bit slice microprogramming class where we I see it in my memory because I found it fascinating of actually how processors worked. And when I first read the Spectre and Meltdown papers, again, a lot of my colleagues, they literally had to read those papers 20 times to grasp what was going on. They were difficult papers, so I had to read them 3 times. But I could do it in 3 times, not 20 times, because I actually had a reasonable base understanding of how processors worked at the hardware level, from the electronics up through the microprogramming, up through to the interface to the operating system. And when we and many other companies postulated not just hardware fixes for this, although there's still ongoing challenges, we also were able to postulate kernel level fixes. It was because there was a bunch of people with actual computer science degrees that had gone from the physics to the people that understand how to get these things done, because it wasn't just a technical problem, it was a people problem, it was an economics problem, it required the alignment and coordination of entire industries. And again, at the heart of all of this are people with solid computer science degrees from places like this, but especially from places like this. So one of the things I will just close, and the final thing I will say, my role on serving on President Biden's Council of Advisors for Science and Technology is one of the things that's interesting is it just proves you're never too old to get imposter syndrome. So on this, the Presidential Council of Advisors is lots of tenured professors, a few Nobel Prize winners, and a lowly engineer with a computer science background who's also on that, representing the field of cybersecurity. So again, one of the things I will just close by saying I'm forever grateful to this place. I remember it every single day, not just because I have fond memories of being an undergraduate and my time at university, but simply because I use this knowledge from this place every single day, and I watch people from other backgrounds that didn't have the education from the physics to the people in an effective computer science degree. And I think this place should continue to be a beacon for that type of education, because the challenges of the future are going to need more of this type of education. So 50th anniversary, congratulations to everybody. I still feel privileged that I was here, and I'm really honoured and privileged to be here today, and I look forward to the rest of the day. Thank you.